Question 8, some differentiation, some of the fun parts. 8.1, given this function f of x equals 3x squared minus 4. They say the first question on this, determine the derivative, or f prime of x, from first principles. Now I'd like to just quickly go through what first principle is. Where do we get this notion from? So let's assume we have this curve here, whatever it might be. And let's assume that this curve is called f. This would be our x-axis, and this would be our output, f of x-axis. Now if we want to find the gradient of this curve at a specific point, let's say there, we can only do that with a straight line, but we can approximate it by taking the average gradient of somewhere else, which is, suppose, this point here. Let's call this value x, and then obviously its corresponding y value would be f of x. Now let's say we take this value, we say it's x plus some distance h, so this distance is obviously h. So x plus h, what would the output be? The output would be f of x plus h. That would be your y value. So now if we take the gradient between these 2 points, that gives us an approximate answer to this gradient. But now if we make this distance between them smaller and smaller, closer we get to there until it's about 0, then we get an exact answer. Now how do we find the gradient? We know that the gradient is equal to the change in y divided by the change in x. And what is it in this scenario? The gradient is the change in y, so one y value minus the other y value divided by the change in x. X plus h minus x. Rewriting this completely, we get f of x plus h minus f of x over x minus x is 0, so we're just left with h. So that's where we derive the formula for first principles from, and that is our gradient. So this denotes a gradient to any function. Okay, now let's get back to the actual question, which was 8.1.1, f of x equals 3x squared minus 4, and we need to find the derivative from first principles. So we just explained that the equation for doing that is f of x plus h minus f of x divided by h as the limit of h tends to 0. Okay, because we want to make that as small as possible, the difference between the 2 points. That's why h has to tend to 0. So we have f prime of x equals f of x plus h, so 3 of, instead of x we've got x plus h squared minus 4 minus f of x, which is 3x squared minus 4. All that divided by h, and don't forget, like me, to put limit of h equals 0. Limit as h approaches 0 of, now let's multiply out this bracket, 3x squared plus 2xh plus h squared minus 4 minus 3x squared plus 4 all over h. Okay, so 3x squared minus 3x squared, that cancels out. Minus 4 plus 4, that cancels out. So we're left with f prime of x equals the limit as h approaches 0 of 3 times 2xh is 6xh plus 3h squared over h. Now we cannot put the 0 in already because then we're dividing by 0, which we know is undefined, so it's not useful to know that. So we'll simplify it a bit by taking out a common factor of h at the top. So we'll take out h and we're left with 6x plus 3h over h, cancel out the h's, Now we can put in the 0. So then you can say the limit as h approaches 0 of 6x plus 3h is equal to, put in the 0, 6x plus 3 times 0, which is 0, so 6x plus 0 equals 6x. So that is our derivative. Nice. Okay, next question, 8.1.2. Let's just rewrite the equation, initial equation again, f of x 3x squared minus 4. The question says that we've got a point A, which is x and 23, and where x is greater than 0, and we've got a point B, negative 2 and y, and they say these 2 points are points on the graph of f. Now they ask us to calculate the numerical value of the average gradient of f between a and b. So the question is, find the average gradient, which is m, between a and b. So we know the gradient is change in y divided by change in x. But we have unknowns. So first thing we need to do is we need to find what these values are. Okay, the b one is easy. The b point, we just substitute negative 2 into the x there. So we'll get y equals 3 times negative 2 squared minus 4. The y value is negative 2 squared is 4, times 3 is 12, minus 4 is 8. So we have that b, negative 2 and 8. And now for a, we need to substitute 23 into the y value. So we've got 23 equals 3x squared minus 4. We want to solve for x now, take the negative 4 across, so we've got 27 equals 3x squared, divide by 3 on both sides, 9 equals x squared, and square root of both sides, we get plus or minus 3 equals x, plus or minus, but we know that x has to be greater than 0, so it's the positive 3 that counts. Okay, so now we have b is negative 2 and 8, and we have a is 3 and 23. So this is what we need to use to, in that equation to find the gradient. So m of ab, or m of f if you like, equals change in y, so 23 minus 8 over change in x, which is 3 minus negative 2, and that is equal to 23 minus 8 is what? 23 minus 8 is 15 over 3 minus minus 2 is 5. 15 over 5 equals 3. So that's your gradient. Okay. What else is there? 8.2. Differentiate the following. Okay, y equals x plus 5 divided by square root of x with respect to x. So we need to find the derivative of this. We don't need to use first principles, which makes it easier and quicker. There are a couple of ways to do this. We want to rearrange the equation somehow. I think for most people the easiest way would be to rewrite it as such, splitting it up. X over square root of x plus 5 over square root of x. And we know that x squared of x is also equal to x to the power half. So y equals x over x to the power half plus 5 over x to the power half. And now we want to get everything to the top of the line so we don't work with fractions. So y is equal to, well, in this case we could just say that's 1 there. When you're dividing by like terms you can subtract the exponents. 1 minus a half is a half. So we're just left with x to the power half in the first term plus 5, and to get this to the top we just make the exponent negative. So 5x to the power negative a half. Now we can use the normal differentiation rule, which is, let me write that at the top here, if y equals x to the power n, then y prime equals nx to the power n minus 1. So that's the rule we're going to use here. So y prime is equal to n, which is that half there, a half x to the power a half minus 1, plus negative, so it becomes minus a half times 5 times x to the power negative a half minus 1. And we want to rewrite that because we always want to leave exponents in positive form. The negative a half minus 1 is negative a half. So we can say that's equal to a half over x to the power negative a half. Okay, and I mean x to the power half at the bottom, positive a half. Minus a half times 5 is 2.5, so 2.5 over negative a half minus 1 is negative 3 over 2, x to the power 3 over 2. And that you can leave that as your final answer, or you can rewrite it in a root form, which I like. It just looks a bit neater to me. So I'll just write this as 1 over 2 times square root x minus 5 over 2 times square root x to the power 3. And that is your derivative, your answer. Okay, so the important thing here is to know how to first rewrite that. Easiest way for me, I think, is to split it up into two parts like this. You could also just multiply the whole thing by square root of x at the top. I mean, not multiply, take the whole square root of x to the top and multiply it into the bracket of x plus 5. Okay, last question in this section, 8.3. Determine the gradient of the tangent of the graph of f of x equals that. Okay, so they give us an equation, f of x equals negative 3x cubed minus 4x plus 5. Again, they tell us find the gradient of the tangent at x equals negative 1. What is the gradient of a function? We know that the derivative of a function is the gradient of that function. And we're looking for a gradient. Okay, and we know that the gradient of a tangent to a function is exactly the same as the gradient of that function at the point where the tangent meets. For instance, on this curve, the gradient of this curve here, let's call it f, is exactly the same as the gradient of that tangent at that point. Let's call that g. So f and g share a gradient at the point of intersection there. That's what we'll use to answer this question. All we need to know is the gradient of this function. And that'll be this, and then we find out what the gradient is at that point. That'll be the same as the tangent. But yeah, to find the gradient of a function, we just differentiate it. So negative 3x cubed becomes negative 3 times 3. That's negative 9x, 3 minus 1 is 2. Okay, minus 4x, so it's just minus 4. Add plus 5, that becomes 0. So this is your gradient of your function, and we want to know what it is at x equals negative 1. So all we do is we substitute negative 1 in. That's negative 9 times negative 1 squared minus 4. That is, negative 1 squared is 1, times negative 9 is negative 9, minus 4 is negative 13. So that's your gradient of your tangent at the point x equals negative 1. And that's it for question 8.